Hello students. So, having understood problem formulation and what problem constitutes of, like formulation, searching and execution, let us go for the next topic of searching. Let's concentrate on searching in the first unit of our open elective artificial intelligence course. So we need to solve it. Once the problem is formulated, we need to identify those set of actions in a sequence that need to be performed so as to reach the goal state. So obviously, to identify the set of sequences, we may be having multiple mechanisms. So we need to think for searching of the solution. So this is done by a search through the state space. Now, this topic deals with search techniques that use an explicit search tree. In this case, we are making use of search tree that is generated by the initial state and the successor function that together define the state space. Successor function gives us the next possible states which can be reached with the legal actions that can be performed on the particular state we are in or the agent is in. So the root of the search tree is a search node corresponding to the initial state. In case of the Romania map that we have observed, it can be taken as in array. So that is the search node from where we start our search. That becomes the root of the search. The first step is to test whether this is a goal state. Now let us suppose that I want to reach Hyderabad. I am already in Hyderabad, so I need not to search further. Now the first thing I should do is, if I am in a particular state, I should check for whether I have reached the goal or not. So goal test is more important because based on the result, we need to continue our search. We need to consider some other states. See, if it is not a goal, then I need to go for another states. So this is to be done. This is done by expanding the current state. What are the other states I can reach from the current state? That I need to consider. So that is applying the successor function to the current state, thereby generating new set of states. For example, if I am in Hyderabad, I need to visit Vijayawada. What are the places from Hyderabad I can visit? First of all, probably I can go to Bombay, I can go to Chennai, I can go to Warangal, I can go to Nalgonda. So these are all the successor states, let us say. But which path will make me to visit Vijayawada? That is ultimate solution I need. So we need to generate the new set of states. The essence of such, following up one option now and putting the others aside for later. So we will do in search, what we will do, we will pick up one option and we will search in that direction. If it is okay, it's okay, or else we will come back and do it in the next direction. In case the first choice does not lead to a solution, we will go for the later ones. So it is important to distinguish between the state space and the search tree, because that we are getting a search tree, we need to understand what is state space and what is search tree. For the route finding problem, like from Arad to Bucharest, there are only 20 states. The different states names we have seen, there are around 20 states, one for each city. But there are an infinite number of paths in this state space. From Arad to Bucharest, you can visit in multiple directions. So all those number of paths are in the state space. So the search tree has an infinite number of nodes. If I am considering the Arad as a root node, expanding it until I reach the Bucharest, I can get multiple things. So that is my search tree. State space is limited, but search tree becomes infinite. There are many ways to represent nodes, but we will assume that a node is a data structure. So because each node has got certain data to be holding with it, we consider it as a data structures having 5 components. So what are those 5 important aspects of the node? One is the state. What is the current state? The state in the state space to which the node corresponds to, that is state. Next thing is parent node. If you have come to a state, from where you have come to this particular state, who is the parent of this state? So the node in the search tree that generated this node is called parent node. Then action. The action that was applied to the parent node to generate this particular child node or the new state. So doing what you have come here from S1 to S2, you have come on A1. This you can correlate with your flat subject where there are transitions on one action from one state to the other, state transition sort of thing. So path cost. What is path cost? The cost traditionally denoted by G of n. G of n is total path cost. Sum of the step cost will give you the path cost. Now of the path from the initial state to the node, whatever the node you are considering up to there, whatever the states you have visited, including the cost of all those will give you G of n as indicated by the parent pointers. Depth, the number of steps along the path from the initial state, how much depth, because it is a tree, we will consider the depth, how depth you have come to reach that particular node. So we also need to represent the collection of nodes that have been generated but not yet expanded. Now the successor function will give me collection of nodes. I need to hold those nodes somehow, so that we call it as a fringe, the data structure which helps me. Now fringe can be implemented in many ways. That is the point, strategy, what happens, because fringe may be a queue, fringe may be a the stack, so that we will see in future. Each element of a fringe is a leaf node. As of now, we consider them as a leaf node. Once we expand it, we will see. So each is an independent one. Now the basic idea of the tree search algorithms, how it works. Offline simulated exploration of state space by generating successors of already explored states, or we are having expanding states, we go on expanding the states. Let us look at the function. Now function search tree is identifying a solution, so it returns a solution if there exists a solution. That means, for example, if I am having a path of let us say if I am having a map of Telangana, in Hyderabad I am, and from Hyderabad I need to reach Khammam, then I will find a solution. But I am having a map of Telangana and I am searching for a solution of reaching Vijayawada from Hyderabad. So that state is not included in my state space. Then obviously it cannot find out the solution. So there is a possibility of failure. So function tree search takes the problem and the strategy. This strategy is basically deciding the search mechanism, how your fringe is being implemented. So that means how you are going to pick up the next node. So it may return a solution or failure. Now initialize the search tree using the initial state of the problem. This continues until you either find the solution or there is a failure. So it's a looping thing. If there are no candidates for expansion, that means you have exhausted all the state space, but still you have not reached the goal state. That means it is a failure. Hence, if there are no candidates for expansion, then return failure. If that is not the case, choose a leaf nodes for expansion according to the strategy. Now, whatever is the next node that you are picking up, maybe the nearest or maybe the longest or maybe less cost or high cost. So what are the strategy it is being implemented? Based on that, pick up the next node according to the strategy. Now if the node contains a goal state, whatever the node you have picked up, you have reached the goal state, then there is no necessity of further expansion. You have reached your goal state, so you can return the path, that becomes your solution. So node of if it is a node contains a goal state, then return the corresponding solution. Else expand the node and add the resulting nodes to the search tree. Now one state I have picked up, one node I have picked up, it is not a goal node. So what should I do? I should see for further nodes that I can reach from this node. So I will expand this node and I need to hold all these nodes which are not yet visited. So that I will store it in the fringe. So all those are pushed to the fringe. This is how your tree search algorithms work. So this is a Romania map. For once again, reference we are putting it here. So tree search example, if I take, I am in Arad, and from Arad we may be going to CBU, Timisoara, Xeret. These are the three successor states which are generated from array. So these gets into the fringe, and then I will pick up one more thing. So I have picked up CBU, and from CBU is not my goal state because I need to reach Bucharest. So I will further expand it. Arad, Fragares, Ordia, and Vilsia. So these are the successor states of CBU. So likewise, we will go for the search. Now, how do we implement general tree search? This is how it works. A tree search takes the problem with a fringe and returns a solution or failure. This we have already discussed. Now, first of all, based on the problem, I need to identify the initial state. So this initial state is put into a fringe by making a node. A node is created based on the initial state, and that is inserted into the fringe. So now my fringe is having one node. Now I will continue picking up from the fringe and expanding if it is not my goal node. So if fringe is empty, that means no more things to expand, no more state or nodes to expand. That means I am failure, I haven't found my solution. So then return failure. Else I will remove front from the fringe. Now from the fringe I am picking up one and calling it as a node, the node which I am considering. So now I need to test whether this node is a goal node or not. So state of the node for the problem, is it a goal or not? If goal, test. If it is true, that means I have reached my goal, then I can return the solution up to that node. Else, what should I do? I should expand. So give this node to the problem and expand it. After expanding, whatever the nodes you are getting, you have to add it to the fringe. So insert all to the fringe. This is how fringe gets updated. Now what actually happens in expand? Expand will return a set of nodes. These are called as successors. Initially a node has got no successors, so I will give them as a empty set. But for each action I may be leading to one successor node. So that we can write it as like state of node. For the problem, we need to find the successor using successor function. So consider the node that is generated as a new node S. For this new node, whatever it is being generated, there is a parent node. So this is being generated from the parent node. You have to link up that. And on what action? So what is the resulted state? These all things are updated. Along with this, as what we have discussed, the total path cost need to be taken into consideration. The path cost of the node plus step cost reaching to that particular node from the parent node. That becomes the total path cost until that particular step, whatever we have done. As well as update the depth by 1 because we have improved the depth, another step has been increased, and add S to the successor, return the successors. This is how implementation of your search tree, general search tree happens.